All right, so let's move on with our discussion on random variables and probability distributions. We don't have time to finish the example 4.6, so I'll just give you the solution 5/8. So we will now move to, we have to prepare ourselves for the first test. So what is the variance? Why do we need to have a variance of a random variable? What is the idea? How we are going to calculate the variance of a random variable? So last week we were mainly discussing the idea of the center of probability distribution of a random variable, and that measure, we use the measure which is called the mean or the expected value. But the mean is not good enough to describe the important features of a random variable. It's the same as your first name. You know, when you give us your first name, is good enough, is not good enough to describe your full name. So that is why we now need to see what is the spread of the values of the random variable. And there are many measures to spread. We introduced some of the measures in the first week, but in this week we'll mainly focus on the variance of a random variable and on the square root of the variance, positive square root of the variance, and the positive square root of variance is, of course, the standard deviation. So speaking of the variance of the random variable, we are going to use several symbols like sigma squared, or when you think about the random variable, sigma squared sub x, to denote that we are thinking about random variable or y or whatever. Or we can use var of x. In many textbooks they use this var of x, or this v can be lower letter v. So what is the nature, what is the formula to evaluate the variance? Now let me remind you about the variance of the population. So variance of the population, sigma squared, is equal to sum of x minus mu squared over n. So this is the variance of the population. But in the case when we have frequencies, then this formula will be changed into the following one. So sigma squared equals sum of x minus mu squared times frequencies divided by the sum of frequencies. And now, according to our most popular theory at this campus, the theory of relative frequency, probability is nothing else but the relative frequency in the long run, which means what? Which means that this f divided by the sum of f is nothing else but the relative frequency, which means that we have to treat that in the long run as probabilities. So this is the hidden link between the variance of the population and the variance of the random variable that we are going to introduce now. So the variance of the random variable is given by this expression, expected value of the deviation squared of the squared deviation. And when you think about the expected value, always translate that as the average or as the mean. So what is the notion of this expression. How we will write this expression in the case of discrete, in the discrete case. So let's try to do that. So E becomes sigma. In the continuous case, E becomes the integral. And now we plug in these values in the parentheses. We square whatever we have to square and copy these values with the lowercase. So small y minus mu of the random variable. And this is not the full expression of the variance. Something is missing here. So what is missing?
I have a question.
Yeah?
Could you explain the f in the sigma square again?
So go on again, sorry.
Could you explain the f in the sigma square equation?
Oh, so what is the f? F is the frequency when you have values like this, x1, f1. Now x2, f2. Blah, 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 x, k, f, k. For example, I'll give you one example. Let's say that in this class we have, not in this, in some step 200 class, there are, with A, we have 5 students. Now B, 8 students. C, 10 students, blah, 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 F, 2 students. So this is practically in the second column here, what we have frequencies. And now if you're looking for the mean result, for the mean grade, then A will become 4, 3, 2, blah, 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 and F, I think 0. Because D is missing, I didn't have time to write D. So to evaluate the mean, to find the mean, it's not good enough to say 5 plus 3 plus 2 divided by the numbers. You have to consider the frequencies. So frequencies are the weights. So the mean value will be 4 times 5. So 4 times 5 plus 3 times 8 plus 2 times 10. And then you have to divide it by the sum of frequencies. In this case, if we disregard this f, it will be 5 plus 8 plus 10. So this is called weighted mean, or the mean in the case of frequencies. And the same applies with the variance. The formula for the variance without this on the left-hand side. So this formula here. This formula is if you don't have frequencies. If you have just raw data. All values are different. So what is the variance? Well, let's try to read this formula. Because we divide this by n, this is a kind of average. So average sum of the squared deviations, that is the variance. Average sum of the squared deviations. But similarly, when you have frequencies, and unfortunately, I haven't seen this formula for the variance with frequencies, almost anywhere. It vanished. But it is important for the deep understanding of statistics. So symmetrically, okay, let me write you the formula of the x bar in the case of frequencies. So this is sum of x times frequencies divided by the sum of frequencies. Now, similarly, when you have the variance, you have to multiply each of these square deviations by the frequency and to divide by the sum of frequencies. All right. Does it make sense now?
Yes, it does. Thank you.
Thank you. Okay, so let's go back now how to evaluate this formula for the variance of the random variable. What is missing in this expression? Sum of the squared y minus mu. What is missing? Probability is excellent. So we have to multiply this by probabilities. Because let me remind you of the formula of the expected value. Expected value of x is sum of x, but we don't leave it like that. We don't leave it like that. We multiply by probabilities. So this is the expected value. So whenever you think about random variable, always take the probabilities, because we live in the probability world. So if you compare now this formula for the variance of the random variable with this formula with the variance of the population when you have frequencies, you can see that in essence we are talking about the same thing, because f divided by the sum of x as the number of elements increases, and finally when the population becomes the infinite one, f of sum of f, sigma f, will become probability. So this stuff here and this stuff here are the same thing according to the classical theory of statistics. These two things are the same. In the same way as this formula for the expected value is the same as this formula for the x bar. So f over sigma f is probability. Here we have probability. So in the long run, expected value is nothing else but the mean. Okay. However, this formula, so let's try to read this formula. What is the variance of some random variable? This is the expected value. Now we are going to translate the expected value with the average. Average of the squared deviations. Average of the squared deviations. So this is the same as here. When you divide by n, it is the average. So average of the squared deviations. This is the variance. Average of the squared deviations. However, this formula here, I'm going to call this a definitional formula. So when you think about the definition, you're going to use this formula. However, in real life, when you're dealing with some problems or example or exercise, we are going to use a different formula. And we are going to calculate variances much more easier. Now, at the bottom of this page, I'm going to prove and to see how we will come up with this working formula for the variance. So let me start. Variance of x is what? Is the expected value of the squared deviations. So x minus mu x. So this is the variance. Expected value of the squared deviations. This is the measure of spread. So let's now square this expression in the parentheses. And please watch out, this is big X. This is the name of the random variable. So let's see what is going to happen. This is expected value of x squared minus 2 big X times mu of x plus mu x squared. So what is going to happen now? This is further equal. Now we will pass through with the expected value for this expression, because the expected value of the sum is the sum of the expected value. The same applies to the sigma. The same applies to any integral. Okay, so this is expected value of x squared minus. Now, when we come to this middle part here, with expected value, two is the constant, and as such, it will come in front of the expected value. So minus 2, and now we have mu x. What is mu x? Mu x is the mean of the population of the random variable, and as such, it is a constant. And as any other constant, we can plug it in front of the expected value. So 2 mu x times expected value of x plus, now we have expected value of mu squared x. This is further equal to expected value of x squared minus, and now what is going to happen with this expression in the middle? 2 mu x, and now we have expected value of x. What is the expected value of x? Expected value of x is nothing else but the mu of x. So this is mu of x. Therefore, this will become 2 mu x times mu x. And finally, this third component, expected value of the mu squared. Mu is the constant, mu squared therefore is also a constant. Expected value of some constant is equal to that particular constant. Therefore, expected value will vanish. So plus mu squared x. And finally, mu x times mu x is mu squared x. And we'll finally get the expression, the working formula for the variance. So this is expected value of x squared minus mu squared of x. What is mu squared of x? Mu squared of x is nothing else but expected value of x squared. So how to read this formula, this working formula for the variance? So from now onwards, we'll be using mainly this expression to evaluate the variance. So what is the variance? Variance is expectation of the squared random variable minus squared expectation squared. So expectation of squared x squared minus squared expectation minus mu squared. And we'll be using this formula many times from this moment onwards. All right, so in all this story, where is the place of the standard deviation? Standard deviation is nothing else but the square root of the variance. Positive square root of the variance. If the variance is 0, the notion is all elements are the same. We don't have a random variable, we have some constant. Variance cannot be negative, standard deviation cannot be negative. All right, any question about this? So let's now move on to practice this. But before that, just let me tell you something. So of course, you can use both of these formula. You can use this formula to calculate variance or this formula. You'll get the same result. But this one is more efficient and quicker to use. You don't have to, as you will see in the following example. So example 4.8, let's find the variance. There are two probability distributions, mass probability distributions, which means discrete random variables. And so we have, let the random variable y represent the number of cars that are used for official business purposes on a work day. The probability distribution for company A is given here, and for company B here. Question: show that the variance of the probability distribution for company B is greater than that for company A. So I will do a variance A, and then you will do variance B. Enough, we have enough free space on the next page. Okay. So this is really essential thing. We must absolutely fully understand what we're doing now. All right, so let's write the formula for the variance. So variance of A, or you can say sigma squared of A is equal to, in our formula, expectation of the squared minus squared of the expectation. Expectation of the squared minus square of the expectation. Instead of x, of course, you can put y, doesn't matter. Or you can use the definitional formula. So let's evaluate this. Let's find, so obviously we need to find the expected value first, and then to find expected value of the x squared. So let's find the expected value. Expected value of x is nothing else but a mu x. I'm interchanging this x and y sometimes because I want you to absolutely ignore whether it is x or y. It absolutely doesn't matter. So this is sum of all x's or y's, doesn't matter. But don't forget to multiply by probabilities. So in this particular case, it is easy to find expected value. So what you have to do is nothing else but to add a new column. So 1 point is 0.3 is 0.3. 2 times 0.4, 0.8, and finally 0.9. So when we add up these values, what we're going to get nothing else but the expected value of this random value, which is 2. So this is really easy. Expected value is 2. And now we need to evaluate the second bit, and that is expected value of the x squared. Any questions so far? Okay, so how we are going to do that? Let's write what we are looking for. We're looking for, so this bit here will be 2 squared. Now this guy here, expectation of the x squared. So let's write it. Expectation of the x squared equals. Now let's apply lotus. So this is because this is a discrete case sigma, and then we copy whatever we have in these parentheses with the small letter x squared and multiply by probabilities. Probabilities will remain the same. Remember that example with the die. Okay, which means what? Which means that the easiest way to do that is to add a new column. Let's start with y squared. So 1 squared is 1, 2 squared 4, 3 squared 9. And now we have to weight these guys with probabilities. So y squared times probability. So 1 times 0.3 is 0.3. 4 times 0.4 is 1.6. 9 times 0.3 is 2.7. So this is 4.6. 4.6. And now it's easy to find the variance. Let's plug in these values in the variance. So 4.6 minus. Now it is a common mistake what I found among many students to subtract the expected value, but they don't square that expected value. So don't make that mistake. So minus 2. 2 is the expected value, but squared. So variance is expectation of the squared minus squared expectation. And this is 0.6. This is 0.6, and this is the variance. Now, before giving you some time to do variance for the probability distribution B, I want to show you something. If you are confused at this very moment with this formula, let me show you how we evaluate variance using the definitional formula. And you then will appreciate why we use this formula here. So let me write the definitional formula. So variance of y equals expected value of y minus mu y squared. So this is the definition of variance, which is in the discrete case E becomes sigma. This thing in the brackets, in the parentheses, we copy the small letter y minus mu y, and we squared it. And of course, we multiply by probabilities. So to evaluate this, to evaluate the variance using this definitional formula, what we have to do is the following. In the original table, we would have to form the column y minus mu y. So from each value of y, we would have to subtract the mean. Then to square this, y minus mu y squared. And finally, this is not good enough. We have to multiply this to weight by corresponding probabilities. So one more column here is needed, and that is y minus mu y squared minus probability. And now you can see that the only reason is to use this formula, expectation of the squared minus squared expectation, instead of the original definition, is the ease of computation. Nothing else but that. Because here, obviously you'll get, some decimal results, blah, blah, blah. We don't want to waste our time. So if you don't have any questions, could you please find the variance of the B? I think 3 times is good enough for that. So please practice. This is the really essential thing that you need to understand 110% in this course. Okay, do we have the variance? Aaron?
1.6.
Excellent. 1.6. That's it. So the variance for the company B is variance for the company B is 1.6, which is larger than variance for the company A. Anyway, now let's move on. Example 4.9. we have now the continuous case. Obviously, just have a look. X can take any value from 1 to 2. The weekly demand for drinking water product in thousands of liters from a local chain of efficiency stores is a continuous random variable. Continuous. Having this probability density. So you have three signals here that you have a continuous case, and therefore you would have to use the integral sign, not the sigma sign. Three signals. So find the variance. Find the measure of spread. So let's take this problem. So variance of random variable x is expected value of the squared of x squared minus square of the expected value. Which means what? Which means that when you use this approach, this definitional formula, the first step will be to find the mean, and then to find the second step will be to find the expected value of x squared, and finally to subtract the mean, the squared mean from x squared. So let's do the first bit here. Let's find the mean of this density. Expected value of x equals, and now by its definition, so this is the continuous case integral that goes theoretically, unbound in general case from minus infinity to plus infinity. However, here x goes from 1 up to 2. So 1 up to 2. And now what? Now don't forget to do the following. Lotus comes again. So big X becomes small x. So you don't simply copy the value of the probability density function. You have to multiply that by x in order to find the center of gravity, which is the mean. So x times 2 times x minus 1 dx. Which is integral from 1 to 2. So the 2 goes in front. So x squared minus x dx, which is further equal to 2. Now let's evaluate now this integral. X squared is x third over 3 minus, now x, the integral of x is x squared half. Integral goes from 1 to 2. So we plug in first number 2 instead of x, minus, we plug in 1, and we'll get 5/3. I really don't have time, unfortunately, now to spend on the evaluation of these simple integrals. All right, so we have this bit here. So this bit here will be minus 5/3 squared. Now we are looking for the expected value of x squared using the same approach. Okay, expected value of x squared, big X squared. Always, when you think about the expected value, always please put the big letter, capital letter. Okay, so this is equal to integral. This integral goes from, again, from 1 to 2. From 1 to 2. Now, plug in whatever is in the parentheses with the small letter x squared and multiply by the probability density function. So what is the probability density function? Nothing else but the weight. This is the weight, the same thing as the probability, but actually, and unfortunately, this is not probability, this is density. It can be larger than 1. So times 2x minus 1 dx. All right, which is equal to 2 times integral from 1 to 2 x cubed minus x squared dx. Which is further equal to 2. Now let's evaluate this integral. X to the power of 4 divided by 4 minus x cubed over 3 from 1 to 2. And the final result is 17 over 6. So this is the expected value of x squared. So let me now find the variance finally. Variance of x, sigma squared x, is another notation, variance of x. You must understand that there are two different notations for the same thing, which is now expected value of x squared minus squared of the expected value. This is the variance. Now this is 17 over 6 minus 5 squared, and finally this is 1 over 18. Now the variance also has its main features, but we're not going to discuss those features today. But we need to absolutely understand those features like variance of the constant, variance of a linear combination, blah, 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 and so on. So example 4.10, I'll skip that. I'll leave it to you to practice. I'll finish our today's class, page 12, just the top part there. And on Wednesday, we will discuss covariance, properties of covariance, properties of variance, and correlation coefficient, Wednesday and Thursday. So these are the main topics for your test 1. And we will organize mock test on Friday. So what I was thinking is the following one, because see how many people we have online. Daniel, Kieran, Sarah, Catherine, and Con. What we're going to do. So
I'll be able to come to class in person next time.
Yeah. So let me see what I'm going to do. On Friday, I'm going to organize a mock test here live, and of course you're going to attend, you people there. And after that mock test, we will go together for the solution, and I will open on the internet. I will open the real test at at 3 p.m. And you have 24 hours to do the test. So the deadline will be Saturday, 3 p.m. Are you happy with that? Okay, thank you. I
Yeah,
think that is the only way really to deal in this corona situation. Everything else will be terribly unfair. Let me just finish, just 1 minute and we will finish. The variance of the function of a random variable. Let me just do this. So this is just the generalization of the variance formula. So variance, and then you have some function of your random variable g, and the question is how to evaluate. For example, g can be 2y plus 1 or 3y or whatever, and this is given by, now again the same thing as with expected value. Expected value of this thing squared, so g of y squared minus expected value of g of y squared. So this is how we are going to evaluate. But this is not going to be the topic, because I will clearly explain you all important features of the variance. You don't need to apply this formula. Okay, so people, I'll see you on Wednesday. So we have 3 days to master these topics: covariance, variance, correlation, and to do the mock test. Any questions? No. No, let me see from our online audience, do we have any questions, people?
I don't know.
No, I'm okay.
Okay, thank you.
There's something due tomorrow, correct, on D2L?
Yes, on detail, just one example, one question.
Was it the one that was earlier in this packet?
Yeah, the one, let me see, that is on page, page 4, example 4.5.
Okay, thank you.
Okay.
Thank you.
I'll see you on Wednesday. Happy Labor Day.